We are going to start now lecture 8 of chapter 10 class 11th mathematics straight lines. So we start this lecture with the topic point of intersection of two lines. We are talking about one line is a1x plus b1y plus c1 is equal to 0. Second is a2x plus b2y plus c2 is equal to 0. These are the two lines we are talking about. If we have to calculate the point of intersection of these two lines, we are saying we are basically solving these two equations and trying to calculate the point of intersection. So when we solve these two equations, we get it is x over b1c2 minus b2c1, that is equal to y1 over, these are the points we are talking about. If the point of intersection of these two lines it is x1 and y1, then x1 and y1 we can calculate using these equations. It is c1 a2 minus c2 a1. We are talking about these coefficients over here. We are using the method of cross multiplications, and this is equal to 1 over a1 b2 minus a2 b1, and using these values we obtain that the value of x and y we have, they are in this form. Next is concurrent lines. So we are talking about three lines are given and they are said to be concurrent if they meet at a point. We are talking about, we have three lines, we are saying they are meeting at a point, then these three lines they are said to be concurrent lines. So if we are talking about three equations, one is a1x plus b1y plus c1 is equal to 0. Next is a2x plus b2y plus c2 is equal to 0, and third is a3x plus b3y plus c3 is equal to 0. And if we have to prove that these three lines they are concurrent, then we have to prove that a1 b1 c1, a2 b2 c2, a3 b3 c3, this determinant is equal to 0. So we are saying that three lines they are concurrent if the determinant of this term is equal to 0. So we are saying that if these are the three equations given to us, p is equal to 0, q is equal to 0 and r is equal to 0, these are the three lines we are talking about, and they are concurrent if there are three constants L, M and N such that L times p plus M times q plus N times r is equal to 0, and the condition we have is that all these constants L, M and N they are not 0 at the same time. So these are the conditions that we have related to the concurrent lines. So based upon this, the first question we have is, if the line ax plus y plus 1 is equal to 0, x plus by plus 1 is equal to 0 and x plus y plus c is equal to 0, these are the three lines given to us, a, b, c being distinct and different from 1 are concurrent. It is being given that these three lines they are concurrent. Then we have to calculate the value of 1 by 1 minus a plus 1 by 1 minus b plus 1 by 1 minus c. So if these three lines they are concurrent, then we are saying that the determinant we have a1 1, 1b1 and 1 1c, this determinant is equal to 0. So if we apply the column operation, that c2 approaches c2 minus c1 and c3 approaches c3 minus c1 over here, this determinant will become a1 minus a1 minus a, then it is 1 1, then it is b minus 1 0 0 and c minus 1, and this value should be equal to 0. Now if we expand this determinant along the first row, we will obtain a into b minus 1 into c minus 1 minus 1 minus a into c minus 1 minus 1 minus a into b minus 1 is equal to 0, and on solving this value we obtain the equation in this form. And if we divide this equation by 1 minus a, 1 minus b, 1 minus c, the answer we obtain it is in this form, that a over 1 minus a plus 1 over 1 minus b plus 1 over 1 minus c is equal to 0. Now this first term, look at this first term. It is a over 1 minus a. We can write this is equal to a plus 1 minus 1 over 1 minus a. We can write this is equal to a minus 1 over 1 minus a plus 1 over 1 minus a. These two terms get cancelled and we are left with this minus 1. So we are writing this term in the form 1 over 1 minus a minus 1. So we obtain the value of 1 over 1 minus a plus 1 over 1 minus b plus 1 over 1 minus c. We obtain this value is equal to 1. We obtain this value is equal to 1, and this is the required value. Next topic we have, it is the family of lines, and we are talking about that any line passing through the point of intersection of the two lines. These are the two lines given to us. One is a1x plus b1y plus c1 is equal to 0, and second is a2x plus b2y plus c2 is equal to 0. These are two equations of lines, and we are saying that any line through the point of intersection of these two lines, it is given by a1x plus b1y plus c1 plus lambda times a2x plus b2y plus c2 is equal to 0, where lambda is the parameter which depends upon the property of that line. So this thing will be more clear to you with our next example. So first question we have over here, it is find the equation of the line passing through the point of intersection of line this, and the condition, the first case it is parallel to this line. So two equations they are given, it is x plus 5y plus 7 is equal to 0, this is one equation of line. Second is 3x plus 2y minus 5 is equal to 0, this is second equation of line. If we are talking about the family of line which is passing through the point of intersection of these two, we are multiplying it with lambda. Why we are multiplying it with lambda is that we have to solve these two equations. Suppose this is equation number 1 and this is equation number 2. So we are saying if we have to calculate the point of intersection, what we are going to do, we are going to multiply the first equation with some constant mu and second equation with some constant, say nu. Then the equation we will write, it is mu times x plus 5y plus 7 plus nu times 3x plus 2y minus 5. This is equal to 0. Now if we collect the like terms over here, we will get it is, if we suppose divide over here with mu and this term we are writing it is lambda, then what we are getting over here, it is x into 1 plus 3 lambda plus y into 5 plus 2 lambda plus 7 minus 5 lambda, and we are saying this value is equal to 0. So this is the family of lines which is passing through the point of intersection of these two lines. Now the condition that is given to us, it is that this line is parallel to this line. So if we calculate the slope of this line, the slope we have, it is minus of 1 plus 3 lambda divided by 5 plus 2 lambda, and that should be equal to slope of this line, and slope of this line we have, it is minus 7 by 2. So solving these two equations, this implies us that 2 plus 6 lambda is equal to 35 plus 14 lambda, and this implies us that the value of lambda we have, it is minus 33 by 8. So this is the value of lambda that we have. In the second case, the condition that is given to us is it is perpendicular to this line. It means that the value of minus 1 plus 3 lambda by 5 plus 2 lambda into the slope of this line we have, it is minus 7 by 2. The product of these two terms should be minus 1. We are talking about this condition. and on solving this we will obtain that the value of lambda we have, it is minus 17 by 35. So the answer in both these cases, in the first case we are saying substituting lambda is equal to, the first case when we substitute the value of lambda is equal to minus 33 by 8 in this given equation, we are talking about this equation, when we substitute this value of lambda, we obtain the equation is 7x plus 2y minus 17 is equal to 0. And when we substitute the value of lambda is equal to minus 17 by 25, this equation becomes 2x minus 7y minus 20 is equal to 0. So these are the two lines that are satisfying the conditions given in this problem, and they are passing through the point of intersection of given two lines. Next equation we have is the equation of a line which is equally inclined with two lines. So if two lines with the slope m1 and m2 are given, we are talking about in this figure, if we talk about, this is the line with the slope m1, this is the line we are saying with the slope m2. We are calculating a line, we are trying to find a line whose inclination with both these lines they are equal. This angle is theta and this angle is also theta. Then we are saying the condition we have is the slope of this line m, it should satisfy this condition that it is m1 minus m over 1 plus m into m1, that is equal to minus of m2 minus m over 1 plus m into m2. So if we calculate the angle between these two lines, we are having tan of theta, that is equal to m2 minus m over 1 plus m2 into m. And if we calculate the angle between these two lines, we have tan theta is equal to m minus m1 over 1 plus m into m1. Now as it is given over here that both these angles, these are theta, it means both these values, these are equal. So we obtain from this that m1 minus m over 1 plus m into m1, that is equal to minus of m2 minus m divided by 1 plus m2 into m. So we are saying that this is the condition that we have when we are calculating a line which is equally inclined to two lines. So next question we have based upon this, we are saying these are the two equations of the lines given to us. We have to find a line which is equally inclined to both of these lines and it is passing through the point 2, 3. So if the new line we are talking about, let its slope is m, then it will satisfy the condition that 3 by 4 minus m, 3 by 4 is the slope of this line. Slope of this line, it is 12 by 5. We are saying divided by 1 plus 3 by 4m, that is equal to, minus sign is there, it is 12 by 5 minus m over 1 plus 12 by 5m. So if we solve this, if we solve these equations, we will obtain that 3 minus 4m into 5 plus 12m, then we have this term when shifted on this side, it is plus 4 plus 3m into 12 minus 5m, it is equal to 0. On solving or opening these brackets, the equation becomes 63m square minus 32m minus 63 is equal to 0. So this implies a 7m minus 9 into 9m plus 7 is equal to 0. So this implies us that the value of m we have, it is 9 by 7 or minus 7 by 9. Now the line having, these are the slopes corresponding to that line and it is passing through the point 2, 3. So we are saying it is passing through the point 2, 3. and the slope of the line it is either 9 by 7 or slope of the line it is minus 7 by 9. So the two equations corresponding to it, they are 9x minus 7y plus 3 is equal to 0 and x plus 9y minus 41 is equal to 0. So we can use point slope form over here to calculate these two equations. So these are the two equations, or we are saying these are the two lines which are passing through the point 2 comma 3 and they are equally inclined to both these lines. Now next we have is two sides of an isosceles triangle are given by the equation. This is one equation and second is x plus y minus 3 is equal to 0, and it is given that the third side it passes through the point 1 comma minus 10. So we are talking about these are the two equations. One is x plus y is equal to 3 and second equation we have it is 7x minus y plus 3 is equal to 0, and this third side it is passing through the point, this, it is 1 comma minus 10. So we have to find the equation of this third side. So it is being given that this triangle it is an isosceles triangle. It means that these two angles we have, they are theta. So this side BC it is equally inclined to both these lines. So if the slope of this side it is m, the slope of this side it is minus 1, the slope of this line it is 7. So what we obtain from this is that 7 minus m over 1 plus 7m, that is equal to, minus sign is there and we get it is minus 1 minus m divided by 1 plus minus 1 into m. So if we cross multiply these terms, we will obtain 7 minus m into 1 minus m, that is equal to 1 plus 7m into 1 plus m. So this is a quadratic equation and it becomes 6m square plus 16m minus 6 is equal to 0. So on solving this we will obtain it is 3m minus 1 into m plus 3 is equal to 0, and this implies us that the value of m we have it is 1 by 3 and minus 3. These are the values of m that we have obtained. Now it is being given that this line it is passing through the point D 1 comma minus 10 and the value of slope we have it is 1 by 3 or the value of slope we have it is minus 3. So the equation of the lines corresponding to both these, they are y plus 10 is equal to 1 by 3 into x minus 1, and corresponding to this it is y plus 10 is equal to minus 3 into x minus 1. So the two equations that we obtain, it is x minus 3y minus 31 is equal to 0, or it is 3x plus y plus 7 is equal to 0. So these are the two equations of the lines, or we are saying these are the equations of the lines that can act over here as the side BC. These are the two lines we have. Now next we have is the equation of the bisectors. So we are considering two lines. These are shown over here in the figure. We are saying this is the line AA dash and this is the line B dash, and the equation of both these lines these are given. It is a1x plus b1y plus c1 is equal to 0, and second is a2x plus b2y plus c2 is equal to 0. These are the two equations of these lines. Then we are saying that the bisector between these two lines, the equation of the bisector, it is given by this equation. So when we are talking about the bisector between two lines, the angle bisector, we are talking about this line over here. So what its property is that if we consider any point over here and we calculate the distance of this point from both these lines, we are saying suppose this point it is x comma y, this is point P, and we are calculating the distance L, P, L and P, M. then we are saying that both these distances PL is equal to PM. The distance between these two, it is equal. So if we consider any general point PXY on this line and we calculate the distance from both these lines, the formula for the distance from the first line, we are talking about this point, it is A1x plus B1y plus C1 divided by square root of A1 square plus B1 square. We are saying mod of this value, that should be equal to mod of the distance from the second line, it is A2x plus B2y plus C2 divided by square root of A2 square plus B2 square. So solving these equations, we get it is A1x plus B1y plus C1 divided by square root of A1 square plus B1 square, that is equal to plus minus A2x plus B2y plus C2 divided by square root of A2 square plus B2 square, and this is the equation we are saying for the angle bisector. So this thing is mentioned over here, that when we are removing this mod, we are having plus minus sign over here, and these are the required equations of the angle bisector. So next question we have is, we have to find the equation of the angle bisector between the straight line. These are the two equations given to us. So we are saying, suppose the locus of the line we are talking about, the angle bisector, it is P, X, Y, these points we are calculating. So what we obtain from this is that 3x minus 4y plus 7 divided by square root of 9 plus 16, that should be equal to plus minus 12x plus 5y minus 2 divided by square root of 144 plus 25. So on solving this, we get it, this value is 5 and this value we obtain it is 13, and on cross multiplying we obtain it is 39x minus 52y plus 91, that is equal to plus minus 60x plus 25y minus 10. Now these corresponding to the plus minus sign, we will have two equations. One is 21x plus 77y minus 101 is 0, and second is 99x minus 77y plus 81 is equal to 0. So these are the equations of two lines which are the angle bisector between these two lines. Why we are getting two lines? We are saying these are the given lines L1 and L2. We can find a line over here which is the angle bisector of this side. This is angle bisector over here. We can find another line in this way which is angle bisector over here. So these are the two lines we are talking about. That is why we are getting the two different lines over here. Next is bisector of the angle containing the origin. So we are saying that again we are having two lines. One, the first equation we have, it is a1x plus b1y plus c1 is equal to 0, and second it is a2x plus b2y plus c2 is equal to 0, where c1 and c2, these are positive. Now we are talking about that pxy be taken on the angle bisector which contains the origin. This is on the side which contains the origin. So if we consider this case over here, we are saying we are having two lines. These are the two lines which are intersecting over here. Suppose we are saying the origin is over here. This is the origin O. Then what angle we are talking about is, we are saying we are having two angle bisector. One is this angle bisector and second is this angle bisector. Now the angle which contains the origin, we are talking about this angle. We are saying this is the angle which contains the origin. It means we are interested in this line. We are interested in this particular line. And we know that the two equations of the line corresponding to it, we are saying suppose on this line we have some point over here, it is p of x comma y. Then we have two equations. One is mod of a1x plus b1y plus c1 over square root of a1 square plus b1 square, that is equal to mod of a2x plus b2y plus c2 divided by square root of a2 square plus b2 square. So based upon this, we have the following conditions. We are saying we have C1 and C2 we are considering they are positive. then we are saying a1x plus b1y plus c1 is greater than 0 and a2x plus b2y plus c2 is greater than 0. Both these values, these are greater than 0. Then we are saying that f1 of xy over f2 of xy, we are saying these two equations we are writing, they are greater than 0, or we are saying the equation of the bisector of the angle which contains origin, it is given by this is positive sign over here. Similarly, if both these values are negative, if both of these values are negative, even then this minus and minus sign gets cancelled and we have the final answer in the positive form. We have this positive equation, both these equations, these are same. So what we obtain is that in both these cases where we are considering that C1 and C2 are positive, then the equation of the bisector towards the angle which contains the origin, it is given by this equation. We are having positive sign for both these values. And if we consider the equation with the negative sign, we are talking about this equation, and we are saying that this is negative sign over here, then we are saying this represents the line towards the side which does not contain the origin. Now next we have to find the angle bisector, bisecting the angle containing these two lines. So look at this line over here, this value C value, it is negative. So we write this equation in the form minus 4x minus 3y plus 6 is equal to 0. And the second equation we write in the form, it is 5x plus 12y plus 9 is equal to 0. So the equation of the angle bisector that we will have, it is minus 4x minus 3y plus 6 divided by this value we will have, it is square root of 4 square plus 9 square. We are writing it with the positive sign, so it is 5x plus 12y plus 9 divided by, we will have 5 square is 25 and this is 144, so we will get 13 over here and this value we will have, it is 5. So this on both sides we are considering the sign to be positive. So this gives us the, on solving this equation, we will obtain the equation in the form, it is 7x plus 9y minus 3 is equal to 0, and this gives us the equation of the angle bisector which contains the origin. Second, for the second equation we are writing the equations in the form, it is minus 4x minus 3y plus 6 divided by 5, that is equal to, we are writing it is 5x plus 12 plus 9, 12y plus 9 divided by 13, and the sign we have over here, it is negative sign. So on solving this equation, the answer we are writing, it is 9x minus 7y minus 41 is equal to 0. So this is the equation of the angle bisector which does not contain the origin. Next is equation of the bisector of the angle between two lines which contain a given point. Now we are talking about, in place of origin, we are talking about any general point. So again we are considering these are the two equations given to us corresponding to two lines. We are saying these are the two lines we are saying. The equation of this line, it is this. The equation of the second line, it is this. We are talking about any point h comma k. Suppose this point h comma k, it is over here. So we want to find the equation of the angle bisector of this side. We want to find the equation of this angle bisector. So the equations of angle bisector, again we have two equations. One is a1x plus b1y plus c1 divided by square root of a1 square plus b1 square, that is equal to plus minus a2x plus b2y plus c2 divided by square root of a2 square plus b2 square. So to find the equation, one of the equation out of these, we are saying that what we have to check is, we are going to calculate the value of a1h plus b1k plus c1, and we are going to calculate the value of a2h plus b2k plus c2. If these are of same sign, then the equation that we will have, it will be corresponding to this plus sign. If they have the same sign, then the equation of the angle bisector corresponding to that angle, that will be with the plus sign. And if they have the opposite signs, then we are saying the equation we have, it is corresponding to the negative sign. So in this case, we solve a problem over here. It is find the bisector of the angle between, these are the two equations given to us, which contain the point 1, 2. So we write both these equations in the form, it is 2x plus y minus 6, and at the point 1, 2, the value we have, it is minus 2, it is negative, and second we have, it is 2x minus 4y plus 7, and the value at 1, 2, it is 1, it is positive. So both these have opposite sign. So the equation of line that we will have, it is 2x plus y minus 6 divided by root 5. This value we will have, it is square root 5. This is equal to, we will have minus sign over here, and this equation we have 2x minus 4y plus 7 divided by this value we will have, it is 4 plus 16, that is root 20, and root 20 we can write this is equal to 2 root 5. So on solving this, we obtain that the equation we have, on solving this equation, the equation we have, it is 6x minus 2y minus 5 is equal to 0. So this is the equation of the bisector of angle between these two lines, which contains the point on the side, which contains the point 1, 2. Next we have is how to distinguish between the acute and the obtuse angle bisector. So we are saying we have two equations, one is a1x plus b1y plus c1 is equal to 0, and second is a2x plus b2y plus c2 is equal to 0, where c1, c2, these are greater than 0. Then the equation of bisectors we have, these are the two equations of bisectors that we have, and in simplified form, these two equations, they are written in this form. We are saying we have cross multiplied these terms and named the new coefficients as p1, p2, q1, q2, these are r1, r2, these are the constants. Now if we are talking about this situation, so these are the two lines we are saying, and these are the two angle bisector. This is one angle bisector, this is another angle bisector. We are saying this is the angle bisector over here, and this is the angle bisector corresponding to this line. Now we know that these angle bisectors, these will be at an angle of 90 degrees. So if we calculate the angle between this line and one of the acute bisector, and we are naming this angle as alpha, then clearly this value alpha will lie between 0 and 45 degrees. That is, we are saying the value of tan alpha will lie between 0 and 1. Now if we are talking about that the slopes we have corresponding to the equation, we are talking about this equation, it has slope m1, and this equation it has slope m2. This equation has the slope m2. Then from these equations we are talking about the slope of this line m1, that will be minus a1 by b1, and slope of this line m2, that will be minus p1 by q1. So the value of tan alpha, that is equal to mod of m1 minus m2 over 1 plus m1 m2, that is equal to mod of a1 q1 minus b1 p1. We substitute these values over here, divided by b1 q1 plus a1 p1, and we are saying if this value that we have calculated, if it lies between this value, we are saying it lies between 0 and 1, then this angle bisector is the angle bisector between the acute angles, and the second bisector, that will be the angle bisector between the obtuse angles. Now suppose we are writing the equations of the lines that are given to us. It is, we are talking about a1x plus b1y plus c1 is equal to 0, and second is a2x plus b2y plus c2 is equal to 0. We are writing them in the normal form. These are the two equations we are writing, where we are saying this c1 and c2 they are greater than 0. Then we are writing this term, this part as cos alpha, this as sin alpha. Similarly, this we are writing it is cos beta, and this term we are writing it is sin beta. So we are talking about the values over here corresponding to this. We are saying these are representing the angle alpha and beta over here, that these lines, the normals of these lines, they make with the x-axis. So if we are calculating the value of cos of alpha minus beta, we are getting it is cos alpha cos beta plus sin alpha sin beta. If we substitute these values over here, we obtain the answer in this form. So what we are saying, that alpha minus beta, that will be acute or obtuse according as cos of alpha minus beta is greater than 0 or cos of alpha minus beta is less than 0. And this is according to the fact that a1 a2 plus b1 b2 is greater than 0 or a1 a2 plus b1 b2 is less than 0. So what we obtain from this is that the bisector of the angle between the lines will be the bisector of the acute or the obtuse angle according to the fact whether the origin lies in the acute or the obtuse angle. That is, it depends upon whether a1 plus a2, a1 into a2 plus b1 into b2 is less than 0 or greater than 0. So we are saying it will be in the corresponding to the acute angle, then we are taking it as less than 0, and it is corresponding to the obtuse angle if it is greater than 0. So how we are going to apply this, we will see in our next problem. So we are given, these are the two equations of the lines that are given. We have to find the equation of the bisector of obtuse angle between these two lines. So corresponding to these two equations, the value of a1 a2 plus b1 b2, that is equal to minus 16, it is less than 0. So we are saying that over here that a negative sign gives the obtuse angle. The negative sign, it gives the obtuse angle. So what we obtain from this is that the equation of the angle bisector between the obtuse, it is 3x minus 4y plus 7 divided by square root of 9 plus 16, that is equal to minus sign over here, it is minus 12 minus 5y plus 2 divided by square root of 144 plus 25. And on solving this, the equation of the line we obtain it is 21x plus 77y minus 101 is equal to 0. So this gives us the equation of the obtuse angle bisector. Similarly, these are the two equations given to us, and we have to find the bisector of acute angle between them. So again, if we calculate the value of a1 a2 plus b1 b2, answer we have it is minus 1 into 7 plus minus 1 into minus 1, that is equal to minus 6. So this value it is negative. So positive sign gives us the acute bisector. So what we obtain from this is that the acute bisector we have it is minus x minus y plus 3 divided by square root of minus 1 square plus minus 1 square. We have positive sign over here, and it is 7x minus y plus 5 divided by square root of 49 plus 1. On solving this, we get the equation in the form, it is 6x plus 2y minus 5 is equal to 0. So this gives us the acute angle bisector. Next is find the coordinates of the in center of the triangle, and these are the sides of the triangle. We are talking about a triangle is there. We are saying this is the triangle ABC. We have to find the in center. So in center is the intersection of the internal acute angle bisectors. We are talking about the angle bisectors we have to draw. These are the angle bisectors, and the intersection of all these three, that will give us the coordinates of the inner center of the triangle. So corresponding to this side, we are saying AB, the equation we have, it is minus x minus y plus 1 is equal to 0. Corresponding to the side BC, the equation we have, it is minus 7x plus y plus 15 is equal to 0. And this third side, it has equation minus x plus y plus 1 is equal to 0. Now corresponding to these two sides, if we calculate the value of a1 a2 plus b1 b2, that is equal to 6, it is greater than 0. So the equation of the internal bisector we have, it is minus x minus y plus 1 upon square root of 2, that is equal to minus 7x plus y plus 15 divided by the value we have over here, 5 root 2. So on solving this, the equation we get, it is 3x plus y minus 5 is equal to 0. So this is the equation of this angle bisector. Next, we calculate the internal bisector of BC and CA. We have these two equations. Again, we calculate the value of a1 a2 plus b1 b2, and we get the answer is 8, and we are saying this value is greater than 0. So the acute angle bisector, on solving this, we are writing the negative sign over here, and the acute angle bisector we have, it is 6x minus 3y minus 10 is equal to 0. So we have obtained the equations of, we are talking about, we have this triangle. We have obtained the equation of angle bisector corresponding to two angles, and the point of intersection of these two. One equation we have, it is 6x minus 3y minus 10 is equal to 0. Second we have is 3x plus y minus 5 is equal to 0. And on solving these two equations, we get x is equal to 5 by 3 and y is equal to 0. And this gives us the coordinates of the inner center of this triangle. This gives us the coordinates of in center.